next question you have to find out the value of theta lying between 0 and pi by 2. And the equation is given as 1 plus sine square theta, sine square theta, sine square theta, then cos square theta, 1 plus cos square theta, and then cos square theta, 4 sine 4 theta, 4 sine 4 theta, and then 1 plus 4 sine 4 theta. This is equal to 0. Now let us simplify it first of all. So to simplify it, operate R2 as R2 minus R1 and R3 as R3 minus R1. Now you will get 1 plus sine square theta, cos square theta, 4 sine 4 theta. R2 minus R1 gives you, this is sine square theta minus 1 plus sine square theta, which will give you minus 1. This and this will give you 1, and this and this is 0. Sine square theta minus this is minus 1 again, this is 0 again, and this is 1. So either you can operate here once more, or you can find the right value like 1 plus sine square theta into 1 minus cos square theta into minus 1 plus 4 sine 4 theta into minus 1 is again plus 1. So ultimately you are left with 1 plus sine square theta plus cos square theta plus 4 sine 4 theta, which will give you, this is equal to 0. This is sine square theta plus cos square theta is 1, so 1 plus 1 is 2, 2 plus 4 sine 4 theta is equal to 0, and sine 4 theta is equal to minus 1 by 2. Now this will give you sine 4 theta is equal to, this is sine of minus, this is pi by 6. Now 4 theta will be equal to n pi plus minus pi by 6, and this will become n pi minus plus pi by 6. This is equal to 4 theta. Now theta will be equal to n pi by 4 minus plus pi by 24. Now since theta lie between 0 and pi by 2, so when you put n here 1, you will get pi by 4 minus plus pi by 24, and this will give you 6 plus 1, 7 pi by 4, and pi by 4 minus pi by 24. This will give you 6 minus 1 into pi by 24, which is 5 pi by 24, or this is 6 plus 1 pi by 24, that means 7 pi by 24, which is not in 0 to pi by 2 in the interval. So now you will put n is equal to 2 here, so that you get pi by 2 minus plus pi by 24. Now when you calculate this will be pi by 2 minus pi by 24, which will be 12 by minus 1 into pi by 24, and this will give you 11 pi by 24, which belongs to the interval 0 to pi by 2. Therefore your answer is theta should be equal to 11 pi by 4. Now the equation cos raised to power 4x minus a plus 2 cos square x minus a plus 3 is equal to 0. You have to find out a solution if you have to find out the value for a. Now here cos square x is equal to minus b. We will apply here the formula minus b plus minus under root b square minus 4ac over 2a. This is equal to now a plus 2 plus minus under root b square, that means a plus 2 whole square minus 4ac, which will make it plus a plus 3 whole over 2a. Now this will be equal to a plus 2. When you simplify this, you will get a square plus 4a plus 4 plus 4a plus 12 whole over 2. Now this will be equal to a plus 2 plus minus under the root a square plus 8a plus 16 whole divided by 2. And this is equal to a plus 2 plus minus a plus 4 whole over 2. Now once you will take plus sign, and you will get a plus 4 over 2. This is equal to 2a plus 6 by 2, and this is equal to a plus 3. On the other hand, you will get a plus 2 minus a minus 4 over 2. This a will cancel out and this will be minus 1. Therefore, cos square x is either a plus 3 or cos square x equal to minus 1. Now this equality cannot be possible. Therefore, neglecting this, and you will take cos square x is equal to a plus 3 only. Now we know that cos square x lies between 0 and 1. Therefore, cos square x is now a plus 3. So a plus 3 should be lie between 1 and 0. From here, subtracting 3 from both sides, you will get 1 minus 3 and 0 minus 3. This will be minus 3 less than equal to a less than equal to minus 2. So this is the required interval for a. Now next question is, if maximum of theta belongs to R, 5 sin theta plus 3 sin of theta minus alpha is equal to 7, then you have to find out the possible value of alpha. To find the possible value of alpha here, first of all we will solve the expression in the curly brackets. So here you have to find out the maximum of theta belongs to R. Now this can be solved as, this is 5 sin theta plus 3, apply here sin a minus b, this will be sin of a cos b minus cos a and sin b equal to 7. This is maximum of theta belongs to R. Now when you will open it, you will get 5 of sin theta plus 3 sin theta cos alpha minus 3 cos theta sin alpha equal to 7, and maximum of this. Now if you take sin theta common here, you will get 5 plus 3 cos alpha into sin theta plus minus 3 sin alpha into cos theta equal to 7. Now we know that maximum value of this expression a sin theta plus b cos theta is under the root a square plus b square. So if we take the value under the root, here a is 5 plus 3 cos alpha the whole square plus minus 3 sine alpha, the whole square. This is equal to 7. Now, this is whole under the root 25 plus 9 cos square alpha plus 2 3 are 6 5 are 30 cos alpha plus 9 sin square alpha is equal to, sorry, this is 7. Now taking 9 common here, sin square alpha plus cos square alpha is 1. So you will get 25 plus 9 plus 30 cos alpha is equal to 7. That means 34 plus 30 cos alpha is equal to 7. Now squaring both sides, you will get 34 plus 30 cos alpha is equal to 49. Now subtracting this, you will get 30 cos alpha is equal to 15 cos alpha is equal to 15 by 30, or cos alpha is equal to 1 by 2. Now this 1 by 2 value will comes out when cos alpha is equal to cos of pi by 3. Therefore alpha will be equal to 2 n pi plus minus pi by 3, which is a required solution for alpha. Now next question is, the value for x belongs to minus 2 pi to 2 pi such that sin x plus iota cos x whole over 1 plus iota is purely imaginary. Now first of all, we will rationalize it to put this expression into standard form. We will get sin x plus iota cos x whole into 1 minus iota over, this is a plus b and a minus b. So you will get a square minus b square, which is 1 minus iota square. And this will be sin x minus iota sin x plus iota cos x minus iota square cos x whole over 1 plus 1, because we know that iota square is equal to minus 1. Now if you take the terms without iota and with iota separately, sin x minus cos x into iota whole over 2. Now this expression will be purely imaginary if sin x plus cos x whole divided by 2 will be equal to 0. That means when its real part is 0, because we know that if you have a complex number a plus iota b, then it is purely imaginary if real part is 0. That means sin x plus cos x over 2 is equal to 0, or if you take root 2 outside, this will be 1 by root 2 sin x plus 1 by root 2 cos x is equal to 0. Or you can say that 1 by root 2 sin of x plus 1 by 2 cos of x should be equal to 0. Now 1 by root 2 is sin of pi by 4 sin x plus cos of pi by 4 cos x should be equal to 0. Now this is sin A. You can take this is sin A sin B plus cos A cos B. This is a formula for cos of x minus pi by 4. Or you can take it another way, like if it is sin x, then for 1 by root 2 you can take cos of pi by 4 plus, and this is sin pi by 4 into cos x. In both ways you can do. This is what? This is sin a cos b plus cos a sin b. So this is sin of x plus pi by 4 is equal to 0. Now we know that in equation 4 sin theta is equal to 0. Theta is equal to n pi. That means x plus pi by 4 is equal to n pi, and this will be x is equal to n pi minus pi by 4. I hope this will be clear to you. Now next is the number of all possible triplets x, y, z such that x plus y plus 2z into cos 2z cos 2 theta plus z minus x into sin squared theta is equal to 0. You have to find out all the triplets x, y, z such that they will satisfy this equation. Now to find these, first of all we will convert this sin squared theta into cos 2 theta by making a substitution. This is 1 minus cos 2 theta by 2 is equal to 0. Now if you will separate the two terms, then you will get x plus y plus 2z plus cos into cos 2 theta into z minus plus z minus x divided by 2 minus z minus x divided by 2 into cos of 2 theta is equal to 0. Now this is x plus y plus z by 2 minus x by 2 is one term, and other is y plus 2z, and this will become minus z by 2 plus x by 2 into cos of 2 theta should be equal to 0. Now this will become x by 2 plus y plus z by 2 plus this is x by 2 plus y plus 3z by 2 into cos 2 theta should be equal to 0. Now if you will compare the coefficient, then you will find that this constant is equal to 0, that means x by 2 plus y plus z by 2 is equal to 0, and secondly x by 2 plus y plus 3z by 2 is equal to 0. Now when you will simplify it, you will get x plus 2y plus z is equal to 0, and here you will get x plus 2y plus 3z is equal to 0, and this is 1 and this is 2, and when you will simplify it, you will get this term and this term will be cancelled out, and you will left with 3z minus z is 2z is equal to 0, that means z is equal to 0. Now when you put this z is equal to 0 in first equation, you will get x plus 2y is equal to 0, that means x is equal to minus 2y. Now if you take y is equal to k, then x will be equal to minus 2k. Therefore this triplet will be minus 2k into k comma 0. Now here you can find, you can put any value of k. So therefore there are infinite values for this triplet x, y, z. Now the equation cos p minus 1 into x square plus cos p into x plus sin p is equal to 0 where x is a variable has real root if p lies in the interval. You have to find out the value for p for which this equation will have a real root. Now we know that any equation, any quadratic equation will have real root if its discriminant will be greater than or equal to 0. That means b square minus 4ac should be equal to greater than or equal to 0. That means cos square p, if you compare it by a quadratic equation ax square plus bx plus c, then this will become cos square p minus 4 times cos p minus 1 into sin p should be greater than or equal to 0. Now cos square p minus 4 cos p sin p plus 4 should be greater than or equal to 0. This will be 4 sin p, so you write here 4 sin p, minus will be plus and 4 sin p will be greater than or equal to 0. Now you will complete the square, you will get cos square p minus 4 cos p sin p plus 4 sin square p. Now this will be 4 sin p minus 4 sin square p greater than or equal to 0. Now this will be cos p minus 2 sin p the whole square plus 4 sin p 1 minus sin of p greater than or equal to 0. Now whole of this expression will be greater than 0. Now you know that this is a square, therefore this will always be greater than 0. And since sin p is less than or equal to 1, therefore this factor cannot be negative. Now suppose if this factor is smaller than this factor, then only just because of this sin p, this can make this factor either negative or positive. That means to make it positive always, whole of this term greater than or equal to 0, this sin p should be greater than or equal to 0. That means sin of p should be greater than or equal to 0. Or you can say that p lies between 0 to pi, because we know that sin p is greater than or equal to 0 when p lies between 0 to pi, that means in first quadrant and second quadrant. Therefore your answer will be 0 to pi. Therefore if p lies between 0 to pi, then this will satisfy the given equation. Now next question is, if sin alpha 1 and cos 2 alpha are in GP, these are in GP, you have to find out the solution for alpha. Now since these are in GP, therefore sin of alpha cos 2 alpha will be equal to 1, because we know that if A, B, C, 3 numbers are in GP, then B square equal to AC. Now to solve this, we will take sin alpha into 2 cos square alpha minus 1 is equal to 1, and this will be sin alpha, this is 2 1 minus sin square alpha minus 1 is equal to 1, and this will become sin alpha 2 minus 2 sin square alpha minus 1 is equal to 1, and this will be sin of alpha 1 minus 2 sin square alpha is equal to 1, and this will be sine alpha minus 2 sine cube alpha is equal to 1, and this will gives you 2 sine cube alpha minus sine alpha plus 1 is equal to 0. Now, if you take factor of this, then you will find that this is possible for this is 2 sine cube alpha minus sine alpha plus 1 is equal to 0, and when you solve it, you will get alpha is equal to n pi plus minus 1 raised to n minus 1 pi by 2. So this is the required solution for the given question that sin alpha 1 and cos 2 alpha are in GP. Next question is, for x belongs to 0 to pi 81 sin square x plus 81 cos square x is equal to 30. Then you have to find out the value for x. Now to solve this, you will first of all put 18 sin square x plus 81 1 minus sin square x is equal to 30. Now this will be equal to 81 into sin square x plus 81 into 81 raised to the power minus sin square x is equal to 30, and this will be 81 sin square x plus 81 over 81 raised to the power sin square x is equal to 30. Now put 81 raised to the power sin square x is equal to t. Therefore, this will become t plus 81 by t equal to 30, or t square plus 81 is equal to 30 t. Now this will be t square minus 27t. Sorry, first of all, you write it directly. T square minus 30t plus 81 is equal to 0. Now you can make the factor minus 27t minus 3t plus 81 is equal to 0. Now from here, t common, t minus 27 minus 3, t minus 27 is equal to 0. From here, t is 3 or t is equal to 27. Now what was t? T was 81 sin square x. That means 81 raised to a sin square x is equal to 3, or 81 sin square x is equal to 27. Now this is 3 raised to power 4 sin square x is equal to 3, 1, and 81 sin square x is equal to 27 can be written as 3 raised to power 4 sin square x is equal to 3 raised to power 3. Now this will be equal to 4 sin square x is equal to 1, or 4 sin square x is equal to 3. Now from here, sin square x is equal to 1 by 4 and sin x is equal to plus minus 1 by 2. From here, sin square x should be 3 by 4 and sin x should be equal to plus minus root 3 by 2. Now since the x should be between 0 to pi, therefore this angle sine of x is 1 by 2, and from here you can take x is equal to pi by 6, and this negative cannot come here, and this plus root 3 by 2 is pi by 3. Out of these two, pi by 6 is in your option, so your answer will be pi by 6. Now, you have to find out the value of x between 0 to 2 pi which satisfy the equation sin x under the root 8 cos square x is equal to 1 are in AP. The common difference of the AP, you have to tell common difference for AP. Now, under the root 8 cos square x is equal to 1 over sin x. Now this is equal to 8 cos square x is equal to cosecant x. Now squaring both sides, you will get 8 of cos square x is equal to cosecant square x. Now for cosecant square x, you will write 8 cos square x is equal to 1 over sin square x, and this is equal to 8 of sin square x cos square x is equal to 1. Now if we take 2 common, you will get 4 sin square x into cos square x is equal to 1, and this will be twice of sin 2x the whole square is equal to 1, or sin square 2x is equal to 1 by 2, and here sin 2x will be equal to 1 by root 2. Now this will be the value when sin 2x is equal to sin of pi by 4. That means this is 2x is equal to n pi plus minus 1 raised to n pi by 4, and this will be x is equal to n pi by 2 plus minus 1 raised to n pi by 8. When you will put n0 here, you will get x is equal to 0 plus pi by 8, and when you will put n is equal to 1 here, you will get pi by 2 minus pi by 8, and this will be equal to 8 is the LCM. This will be 2 4 pi minus pi. This will be 3 pi by 8, and again when you put n is equal to 2 here, then this will be x is equal to pi, 2 will be cancelled out, this will be plus pi by 8, and this will be equal to 9 pi by 8. Now this pi by 8, 3 pi by 8, and the terms are in AP, and its common difference will be given by 3 pi by 8 minus pi by 8. This is 2 pi by 8, and this is pi by 4. Therefore, common difference for the given equation is pi by 4. Now you have to find out the number of solution for the equation tan x plus secant x is equal to twice of cos x. Now this will be 1 sin x over cos x plus 1 over cos x is equal to 2 cos x, and this will be equal to 1 plus sin x over cos x is equal to 2 cos x. This will be 1 plus sin x is equal to 2 cos square x, and this will give you sin x is equal to 2 cos square x minus 1. Now here you can factorize it so that this will be sin x to 1 minus sin square x minus 1, and this will be sin x is equal to 2 minus 2 sin square x minus 1. This will be 1 minus 2 sin square x, and this will become 2 sin square x plus sin x minus 1 is equal to 0. Now here sin x will be 2 sin x square x plus 2 sin x minus sin x minus 1 is equal to 0. Now here when you will solve it, you will get twice of sin x into sin x plus 1 minus 1 sin x plus 1. Now this is 2 sin x minus 1 is equal to 0, or sin x plus 1 is equal to 0. Now this is 2 sin x minus 1 equal to 0, 2 sin x is equal to 1, and sin x is equal to 1 by 2, and here sin x is equal to minus 1. This is 3 pi by 2, so we'll take this, and here sin x is equal to 1 by 2, that means sin of pi by 6, and x will be equal to n pi plus minus pi by 6, or you can write n pi plus minus 1 raised to power n pi by 6. From here, there are only two values, one is pi by 6 and other is 5 pi by 6, which are in the interval. Therefore, its number of solutions are 2. Now, you have to find out number of all possible triplet A1, A2, A3 such that A1 plus A2 cos 2x plus A3 sin square x is equal to 0. This type of question we have already done. So in a similar pattern, you will take this A1 plus A2 cos 2x plus A3 1 minus cos 2x divided by 2. This is equal to 0. Now this is A1 plus A2 cos 2x plus A3 by 2 minus A3 by 2 cos of 2x is equal to 0. Now when you take these two terms together, plus A2 minus A3 by 2 with cos 2x is equal to 0. Now comparing coefficient, this will be a1 is equal to minus a3 by 2 and a2 is equal to a3 by 2. Now if you will take a3 is equal to k, a constant, then from this point a3 by 2, a1 will be equal to minus k by 2, and from point a2, a3 by 2, this will be equal to k by 2. Therefore, triplet will become a1, a2 and a3. So for k we can find infinite values, therefore this triplet will have infinite values. Now next question you have cos 2x plus a sin x is equal to 2a minus 7. You have to find out the value for n for which this equality will hold. Now first of all we will take left hand side, which is cos 2x plus a sin x. Now if you open this, 1 minus 2 sin square x plus a sin x. Now you know that this 1 minus 2 sin square x plus a sin x is equal to 2a minus 7. Now when you take this side on right hand side, you will get minus a sin x plus 2a minus a is equal to 0. Now here sin x will be equal to minus b plus minus under b square minus 4a into c whole over 2a. Now we know that this will hold if sin a square minus 4 to the 8 2a minus 8 will be greater than or equal to 0. And also we know that sin x lie between minus 1 and 1. So you can take by both sides, either you can put this into minus 1 to 1, or you can take a square minus 8 2a minus 8 is greater than or equal to 0. That means 8a square minus 16, 8 to the 16, a plus 64 greater than or equal to 0, or a square minus 16a plus 64 greater than or equal to 0, or a minus 8 the whole square is greater than or equal to 0. This is 8 to the 16. Or you can write that since sin x lie between minus 1 and 1, so you can write here since sin x lie between minus 1 to 1, therefore whole of this term must be lie within minus 1 and 1. That means put equality here. This will be less than a plus minus. This is a minus 8 as we have proved it earlier. So this will be minus 4 less than or equal to a plus minus a minus 8, 4. Now we will neglect minus term because otherwise a will cancel out. So we will take only plus value, and this will be a plus a minus 8 will be in between minus 4 to 4, and this will be minus 4 2a minus 8 less than or equal to 4. And here you will get minus 4 divided by 2, you will get a minus 4 less than or equal to 2. Now when you add this, By solving this, you will get A is in between 6 and 2. So your answer will be A will lie between 2 to 6. Now you have A is equal to sin square theta plus cos 4 theta, and you have to find out limit for A. So this will be 1 minus cos square theta plus cos 4 theta, and this is equal to cos of 4 theta minus cos square theta plus 1. Now if you put cos square theta is equal to t, you will get A is equal to t square minus t plus 1. You can put this t square minus t plus 1. Now we know that its maximum or minimum solution is given by minus b over 2a. Either you can find the value, the limit for sin square theta plus cos 4 theta in this way, as this will be, if you put minus b over 2a here, so this will be 1 by 2, and here if you put 1 by 2, you will get 1 by 2, 1 by 4, plus this will be again plus 1 by 2 plus 1, and this will be 4, 2 plus 1. This is 4, and let's say A is equal to cos 4 theta minus cos square theta plus 1. Now its maximum value we can find out by putting or by converting it into a single multiple angle, like sin square theta is cos 4 theta minus, इस क्वेश्चन को दोबारा से करना. Now you are given that A is equal to sin square theta plus cos 4 theta. Now you have to find out that the limit of A. Now limit of A will lie between this sin square theta can be written as 1 minus cos 2 theta over 2, and this cos 4 theta can be written as cos square theta the whole square, and this can be written as minus cos 2 theta by 2 plus this is cos square theta, and you can write it 1 plus cos 2 theta by 2 the whole square. Now again this can be written as 1 by 2 minus cos 2 theta by 2 plus, take 1 by 4 outside, you will get 1 plus cos square 2 theta plus 2 cos 2 theta. Now this will be 1 by 2 plus 1 by 4 minus cos 2 theta over 2 plus 1 by 4 cos square 2 theta plus cos 2 theta by 2. Now this will be cancelled out, and ultimately you will left with this is 1 by 4 plus 1 by 2, and when you add this you will get 2 plus 1 by 4 minus plus 1 by 4 cos square 2 theta, and this will be 3 by 4 plus 1 by 4 cos square 2 theta. Now we know that the maximum value for cos square 2 theta is 1 and minimum value for cos square theta is equal to 0. Now therefore its minimum value will be given by 3 by 4 plus 0 is equal to 3 by 4, and when it will be maximum, then cos square theta will be equal to 1. That means 3 by 4 plus 1 by 4, and this will give you 4 by 4, which is equal to 1. Therefore the value of A will lie between 3 by 4 and 1. Now the minimum value for sin 6x plus cos of 6x, you have to find out the minimum value for sin is 6x plus cos is 6x. To find its minimum value, first of all we will write it like sin square x plus cos square x, the whole square, minus 3 sin square x cos square x into sin square x plus cos square x, because we know that a cube plus b cube is equal to a plus b, the whole cube minus 3ab into a plus b. Now if you take a is equal to sin square x here and b is equal to cos square x here, then you will get this. Now this is equal to 1 minus 3 sin square x cos square x. This is again equal to 1. So you are left with 1 minus 3. Now if you multiply it by 4 and divide by 4, you will get 4 of sin square x into cos square x. And this will be equal to 1 minus 3 by 4 sin square 2 alpha. Now we know that, again same as we had done in the earlier question, that sin square 2 alpha, the value for maximum value and the minimum value for 1 minus 3 by 4 sin square 2 alpha, and the maximum value will be for sin 2 alpha will be equal to 1 and minimum value will be equal to 1. Now since this is 0 minimum value. Now for this, since this part is in negative, therefore if you have to find out minimum value, then this term should be maximum. For this term should be maximum, sin square 2 alpha should be maximum. Now for maximum, sin square 2 alpha we will put 1 here, so we will get 1 minus 3 by 4 is equal to 4 minus 3 by 4, this is equal to 1 by 4. Therefore minimum value for this expression is 1 by 4. Now next question you have, you are given that if in a triangle a cos square c by 2 plus c cos square a by 2 is equal to 3b by 2, then sides of triangle are in AP, GP or HP. Now to find this, first of all we will solve this. Now we know that a cos square c by 2 is what? This is 1 plus cos c by 2, and plus small c, this is 1 plus cos a by 2 is equal to 3b by 2. Now this is a by 2 plus a by 2 cos c plus c by 2 plus c by 2 cos A is equal to 3b by 2. Or you can write a plus a cos c plus c cos A is equal to 3b. Now take a and plus c together, plus a cos c plus c cos A. This is equal to 3b. Remember this thing, this is a capital C and this C is small c. This is a side and this is the angle. Now, if you take A over sine A is equal to B over sine B equal to C over sine C, which we have done, then this A will be C, let this be equal to K, this will be equal to A is equal to K sine A, and this C will be equal to K sine C. Now if you put this value here, so you will get A plus C plus K sine A cos C plus K sine C cos A is equal to 3b. From here, you can write A plus C plus, take K common, you will get sine of A cos C plus cos A sine C is equal to 3b. Now, A plus C plus K times, this is sine of A cos B plus cos A sine B. So this will be sine A plus B, that means sine of A plus C is equal to 3b. Now since ABC are angle of a triangle, therefore capital A plus capital B plus capital C will be equal to pi, and here A plus C will be equal to pi minus B. Now put this pi minus B here, so you will get A plus C plus K times sine of pi minus B is equal to 3b. Now this sign pi minus B will be equal to A plus C plus K sine of angle B, because pi minus theta is pi theta only, and A plus C plus K times this will be equal to B over K. From the sine formula, A over sine A is equal to B over sine B is equal to C over sine C is equal to K. This will be A plus C plus this K will cancel out. You will left with B, 3b, and A plus C will be equal to 3b minus B, and this is equal to A plus C is equal to 2b. Therefore ABC, which is a condition for AP, therefore ABC are in AP. Now you are given that 3 sin A is equal to 6 sin B is equal to 2 root 3 sin C. Then you have to find out angle A. Now here you can take sin A over 1 by 3, sin B over 1 by 6, and sin C over 1 by 2 root 3. That means the sides ABC are in this ratio, and if this will take K, then this will be equal to sin A is equal to 1 by 3K, sin B is equal to 1 by 6K, and sin C is equal to 1 by 2 root 3K. Now since we have to find out angle A, therefore you can write the formula for cos A, which is equal to B square plus C square minus A square over 2BC, and when you put the value for all these BCA and BC here, from here, then this will be cos of A. This B is, let this is K of sin B. B is K of sin B. Let us consider once more sin A over A plus is equal to sin B over B equal to sin C over C is equal to K. And when you will put B is equal to sin B here plus C is K sin C, A is K sin A, B is again K sin B, and C K sin C. And when you will solve it, then you will get cos A is equal to 1 by 2. Therefore, from this A will be equal to pi by 3, which is the required answer to find out angle A.